At the beginning of section 5.6, where we looked at recursion, one of the things we brought up was the idea of Fibonacci numbers. Let's take a look at this again and then solve one of the problems in your text dealing with Fibonacci numbers, like the kind I'll expect you to be able to do. The Fibonacci numbers, if you remember, started with this problem dealing with rabbits, and it dealt with pairs of rabbits. But the general mathematical idea is we have a 0th and a first entry or seed into this Fibonacci sequence. And then each of the subsequent ones are done with a recursive formula where we add the two previous ones together. And that's what we do for all of the terms starting at f sub 2. So you can see then that f sub 2 is going to be f sub 1 plus f sub 0, so it's 1 plus 1, so the next one is 2. Then we take f sub 2, which we've just calculated to be 2, add f sub 1. When we add those together, we get 3. We're going to take the 3, add it to the previous one, which is 2, to get 5. We're going to take the 5, add the previous one, which is a 3, to get 8. And by now, you can kind of see the way this pattern works, because what we do is we add the 5 and the 8, and we get 13. We add the 8 and the 13 to get 21. We add the 21 and the 13 to get 34, and so on. And we've mentioned before how this pattern appears many places in nature and in the real world. We jokingly say there's a Fibonacci conference every year, and this year it's going to be as large as the last 2 years combined. Now when you look at this is an easy formula to express in a recursive form. But if you were going to try to find an explicit form for this, that looks a lot more challenging. And it is. In fact, it's just a little bit beyond what we're going to do in this class. But there is an explicit formula for that. And if you're really interested, we're not going to do it, but it's in the section right after where we leave off. It's on page 323 and 324. And the explicit formula looks like this, which looks really weird because it has this square root of 5 in it. But even though it has a square root of 5 in here, when you go through and put in your values for n, this thing works out to always yield integers. If you're really interested, you can take a look at that, and it isn't really something that's all that abstract in some ways, because what these things involve are the golden ratio, which leads into a whole nother area of mathematics. But this version of the Fibonacci numbers, where we're going through and adding the two previous ones together to get the next one, is not the only form of a Fibonacci sequence. You see, we could mix this up a little by simply changing the initial two conditions. Or we could involve it a little bit by going back not 2 before, but maybe 3 before. Or we could put a multiplier in front of these, one of these as a coefficient. The next problem that we're going to look at does that kind of thing.